Okay, so we're going to start by talking about the hills and valleys in a graph. And those are called the relative or local extrema. Okay, so on the AP exam you might see them called relative extrema or local extrema, same thing. Okay, so the hills are called relative or local maximums and the valleys are called relative or local minimums. Okay, so we'll get back to those in a minute. But first we're going to talk about something else. Okay, so first we're going to start by talking about absolute extrema, which is not the same as relative or local extrema. Okay, let's first talk about the absolute extrema. The absolute extrema are exactly what you think they are. Okay, so for example, the absolute maximum would be the absolute highest y value or f of x value of a function. The absolute minimum would be the absolute lowest y value or f of x value. Okay, now that's just kind of like an informal definition of what these are, but you should understand the formal definitions as follows. Ready? So when you open up your book, this is how it's going to explain it. A function f has an absolute maximum at x equals c if f of c is greater than or equal to all other y values or f of x values for all x in the domain of f. Okay? So all that's saying is the y value at c is greater than or equal to all other y values. Wouldn't that make sense? That would make it the maximum value, right? Okay? Same thing with a minimum. The function f has an absolute minimum at x equals c if the y value there, which is f of c, is less than or equal to all other f of x or y values for all x in the domain of f. Okay, so there's the formal definition. Okay, now we're going to switch from absolute to what? Relative or local. And again, this is the problem on the next test that I was talking about. When students can mix these up, obviously it's going to be a disaster if you're continuously mixing these up, because 80% of the next test is going to be fine absolute or local mins and maxes. And so if you don't know the difference between the two, obviously it's not going to go well. Okay? So, what do I mean by a relative or local extrema? Again, informally, a relative or local maximum would usually be a y value or f of x value at the top of a hill. A relative or local minimum would usually be a y value or f of x value at the bottom of a valley. Okay, so that's the informal definition of what I mean here. Now these are the formal definitions as you would see them in a textbook. Ready? A function f has a local maximum at x equals c if you can find an open interval, and that's the key there. If you can find an open interval containing c such that the y value there, in other words f of c, is greater than or equal to all other y values in the interval. Okay, and then kind of in a similar way, a function f has a local minimum at c if you can find an open interval containing c such that, again, the y value or f of c value is less than or equal to all other y values in the interval. Okay, so based on the formal definition, all of these would be examples of relative extrema. Are you ready? Okay. That would be a what? Local or relative what? Max. Why? Because I have this open interval here, right? Where what? That is greater than or equal to what? That y value is greater than or equal to what? All other y values. Is that clear? Okay. Again, see how you can find an open interval here where that's the lowest point? That makes that a what? A local or relative what? Min. Okay, what's that? A local max, right? Because again, here's an open interval, right? Where that y value is greater than or equal to all other y values on the interval, right? So that makes that a local what? Max. What about this? Local min, local max. Now, you might not think this is, but it is. Just think about it. Isn't that an open interval where that is greater than or equal to all other y values, making that a local max, but it's also a what? Local min as well, isn't it? Right? Because isn't that y value less than or equal to all other y values on the interval? So technically, that point, or any point here really, except on the end point, okay, So any point in there except the endpoints would be both a local max and a local min. Is that clear? By definition, yes. The problem is with it being at the endpoint, if it's at the endpoint, then you can't find a what? Open interval, and that's the key. If you can't find an open interval where that's the case, then you can't classify that as a local extrema at all. That's why I emphasize you got to find an open interval. Got it? So it can't be an endpoint here. Can it? No. Can this be an endpoint up here? Yes? Yes. Okay? This doesn't say anything about an open interval, does it up here? No. So the absolute min and maxes can be at an endpoint, but a local min or max cannot be. Okay. All right, so graphical examples of what I'm talking about. Okay, just look at this graph. Do you agree it has no local max? Agree there's no local max? Right? There's no hill, so to speak. Is there a local min? Yeah, where? Right here. So it looks like at about what? F of 3 equals -2, right? What's the absolute max? In other words, what's the absolute highest y value? 4? Yes? And it occurs at what? -2. Is there an absolute min? Yeah, where? Down here. What's the absolute lowest y value? -2, and it occurs at what? 3. Okay, what about here? Look at this graph. Is there a local max? Yeah, where? Right there at the top of the hill. Is there a local min? No, no local min. What's the absolute max? Again, top of the hill, right? Yes? The absolute max is 3, and it occurs at what? 2. Okay, what's the absolute min? Well, it looks like the absolute min is what? 1, but it occurs at 2 different y values. What are they? -2 and 5. Are you getting this, guys? Okay. What about this one? Is there any local maxes, any hills? Yeah, where? There. So at the point 1, 3, right? There's a local max. Is there a local min? Yeah, where? 3 what? -1. What's the absolute max? The absolute max is what? 4, and it occurs at what? 6. What's the absolute min here? -2, right? And it occurs at what? -3, right? You getting this? Yes?
Why can't the local min be at -2.5?
Right here? Because there's something lower. You mean here?
Well, I mean, like, it's lower than, like, at 3.
Okay, again, you can't confuse absolute min with local mins. Put it this way. Absolute are the absolute highest and lowest, okay? Get that straight first, right? Now, locals, in order to have a local min, you have to find an open interval where it's greater than or equal to all other y values. So the reason that's a local max is because you can find an open interval there, say from there to there, where that's greater than or equal to all other.
Well,
You can't find an open interval here because there's nothing to the left of it. So how could you find a...
Well, just to the right of that then. Like,
Okay, you can, right, but you've got to be able to find something to the left of it too.
well, yeah.
You have to find an open interval where that's lower than or equal to all other y values in order to classify that as a local min. Well, there's no graph to the left, so you can't find a interval over here because there's nothing to the left over here. There's nothing.
No, I mean, but, like, when the, like, open interval was to the right of the point.
Right, but you have to have a right and a left. You can't just talk about to the right. You have to have an open interval, right and left.
The left.
No, you can't. There's nothing to the left of that. See what I mean? See what I mean?
Saying, like, if it's like at like -1, but like then there's something lower to the left of it, which would then be like the absolute min, but then you have to go to the left again, and it still keeps.
Yeah, then there's something lower then. You see what I mean? There's
Until there's nothing there. Like you're saying.
the bottom line is,
There has to be a hill or a valley.
yeah, that's the bottom line. That's why I try to give you the informal definition is basically it's got to be a hill or valley or it's not going to classify as a local min. Got it? That's the easy way to remember it if it's confusing you. But by definition, think about it. I cannot find an open interval, right? containing the graph where that's lower than or equal to all other. I can't. I can find open interval part of it to the right, but not to the left, because there's nothing to the left. That's the bottom line. Okay? Okay. By the way, start making some notes here, guys. What do you notice at the top of the hill and valley? The derivative is what? There's a sharp turn, so the derivative would be what? Undefined. So just make a note of that. I'll tell you why in a minute. Okay, what about here? Is there a local max? Well, there would be the one there, but there's no point there, so there's no local max there, even though you might think there is. Clearly there's not, because what would be the highest point is not there. Got it? So there's no local max there. There's no local min there, so there's no local min or max at all here. What's the absolute max? 5, and it occurs at what? 6. And then do you agree there's no absolute min? Why is there no absolute min? Because what would have been the lowest point is what? Open. So what are you going to tell me that the lowest y value is? Negative 2.9? No, there's something lower, negative 2.99. Well, there's something lower than that, isn't there? Negative 2.999? Do you agree that no matter how you try, there's no low point here? Do you agree there's no low y value here? So there's no absolute min there either. Okay? All right, what about here? Is there a local max? In other words, is there a hill? No. Is there a local min? Yeah, right there, right? At what, 3, negative 2? Is there an absolute max? No, because this keeps going up and up forever, doesn't it? Okay, what about absolute min? Is there an absolute min? Yeah. Right there as well, right? So see how the absolute and local min can sometimes be the same and sometimes they're not the same, right? Okay. All right, so based on all 5 of those graphs, you should agree with the following observations. Are you ready? Number 1, the absolute min or max can only occur where? At a what? Endpoint of an interval, or at a what? Local min or max in between the endpoints of the interval. Does that make sense? Again, you shouldn't have to memorize that. If you think about a bunch of different scenarios, that should make sense. Okay? When you try and memorize things, that's when you forget them, right? So think about that instead of just memorizing it. The second thing you should get out of those 5 graphs is that when you do have a local min or max, what should happen? The derivative should either be what? 0 or undefined. As you can see, what's the derivative there? 0. What's the derivative there? 0. What's the derivative there? Undefined. What's the derivative there? Undefined. What's the derivative there? 0. So do you agree with that observation? That when you do have a local min or max, the derivative is 0 or undefined. All right, now, well, wait. I know the mistake you're going to make. And even though I'm going to try and stop you from making this, sure enough, some of you are going to come up after the next test and say, why is this one wrong? Well, again, it's because of this right here. When you do have a local min or max, the derivative is 0 or undefined. But does it work the other way? And you remember in geometry when you made a statement and you said it was true, and then your teacher might have asked you, well, is the converse of that statement true? And sometimes it is and sometimes it isn't. Is the converse of that statement true? In other words, just because the derivative is 0 or undefined, do you automatically have a local min or max? No. Well, here's an example. Isn't the derivative there undefined? Do you have a local min or max there? No. Same thing here. Isn't the derivative there undefined because of the discontinuity? Do you have a local min or max there? No. So what I'm saying is it works this way. The statement works this way, but it does not work that way. Is that clear? Yes? Right? So don't make that mistake. Okay. Let me staple this. Okay, so that leads us to a new vocabulary word, which is a critical number. So what's a critical number? A critical number of a function f is an x value, c, where f of c is defined, first of all, and on top of that, the derivative is either what? 0 or what? Undefined. So again, In order for an x value to be a critical number, first of all, f of c has to be defined. And then from there, if the derivative turns out to be 0 or undefined, then c would classify as a critical number. Is that clear? Okay. So again, this is what I was talking about a minute ago. We have just seen that if f has a local min or max, the derivative has to be 0 or undefined. However, the converse of that statement is not true. In other words, just because you have f prime equals 0 undefined does not automatically mean you're going to have a local min or max. And again, here are a couple examples. What's the derivative there? What's the derivative? 0. Do you have a local min or max there? No. What's the derivative there? Undefined. Do you have a local min or max? No. Okay, so again, don't fall into that trap. Okay, the good news is this first example I worked out for you. Okay, so I want to find the critical numbers of this function. Okay, and so, by the way, these radical problems are the problems that were commonly missed on that last test. And again, it's because I don't think you guys are taking your time enough on the homework to do the radical problems correctly. You're either not finishing them or you're just copying what's on Moodle, and you're not actually learning how to and practicing how to simplify these. And that's the key. You're not going to get a problem like this right on the homework tonight or on the next test if you're not able to work with the radicals completely to the end. Okay, so let me go through this slowly. That's why I typed it up for you so you can watch. Ready? Here we go. Okay, so to find the critical numbers, obviously we're going to need to find the derivative. Now before you do that, is it okay if I write this as x to the 1/3 for derivative purposes? Is it okay if I write that as x to the negative 2/3 for derivative purposes? Okay? All right, so here we go. So just do the power rule for derivatives. So the derivative of that is that. The derivative of that is that. And then I simplify it down to here. And by the way, look at those. Which one can be simplified? Which one can't? Well, remember from Algebra 2, if that exponent is less than or equal to, let me say that again. If that exponent is greater than or equal to the root, that's when you can keep simplifying. Well, I can't simplify that one, so leave it alone. Can I simplify this one further? Yes, because that 5 is greater than the root of 3. And so what I did is, off to the side here, I just rewrote that as that, and then the cube root of x cubed just turned into x, didn't it? Leaving me with this. So I just replaced all of that with that. And then from there, how do I get a common denominator? Well, I need to multiply this first one by what? By x over x to get a common denominator, don't I? So just multiply that first one by x over x. Then I bring them together under one fraction. Okay? And that's as far as you're going to be able to go. Everybody see what I did there? All right, now let's look at that. That's the derivative. Where is the derivative 0 or undefined? Well, it's going to be 0 when the what? When the numerator is 0, and that's at what? That's at what? Negative 2. Where is that derivative undefined? Well, when the denominator is 0, which is at what? 0. So it looks like we might have what? Two critical numbers? Agreed? Hold on. Wait. With me? Yes? With me? Gloria, with me? Yeah? Okay. All right. Now, what else do I have to check for? F of c had to be what? Defined before I can call them both critical numbers. Okay. So if I stick a negative 2 back into here, do I get a value? Yeah. Because the negative 2 squared becomes positive. So, okay, and then you have the cube root of a positive here. You have the cube root of negative. You can take the cube root of a negative, can't you? You can't take the square root of a negative, but you can take the cube root of negative. Okay, so f is defined there. Okay, so that's definitely a critical number. What about at 0? If I stick 0 into the original function, is it defined, yes or no? No, because here I end up with a 0 in the denominator. So what I'm saying is 0 is not a critical number. So the only critical number is what? What is it? Negative 2. Are you following me, guys? Okay. All right, I want everybody to quickly do example 2. Give it a shot. Okay? can't break. Yeah. All right, guys, ready? Here it goes. Okay, we got to find the critical numbers, so clearly we're going to find the derivative first, which is this. And then you got to figure out where that's 0 or undefined, right? Well, in order to do that, we're going to need to factor, aren't we? Okay, so who has the factorization? Go ahead. 3x minus 1, 3x plus 1. Everybody agree with that? I'm sorry, x plus 1. Sorry. Is that right? Good? All right, I agree. And so now, when is it 0 or undefined? Well, it's never going to be undefined, but it's going to be 0 at what? When this is 0, which is at what? At 1/3, right? And this is going to be 0 at what? At -1. Okay, so it looks like we might have two critical numbers. Now, in order to box these in as critical numbers, what has to happen also? The original function has to be what? Defined. Do you see any problems with sticking a 1/3 in there and getting a value? No. How about -1? Okay? So, yes, these are both critical numbers. Got it, guys? Okay. Okay. Now, I'm going to have a question like this, I'm sure, on the next test, on the calculator part. Now, what's different here? This time I gave you what? I didn't give you f, I gave you what? F prime. So all you got to do is what? Graph this and see if it's ever what? If it's ever what? 0 or what? Undefined, right? Okay. And by the way, let me tell you this. Oh, wait, we won't get into that right now. Okay, so let's just do this. Okay, so I don't need to take the derivative here, right? I already have the derivative, don't I? Do you agree I don't need to do any derivatives here? I already have the derivative, right? Okay, so I'm going to start by hitting zoom Z standard. And then make sure I'm only on the interval 1 to 3, not including 1, right? So, all right, now it's kind of hard to see what's going on. So, how do I spread the graph out vertically, guys? How do I stretch it out? By changing my what? My what? Y min and max, okay? So I don't think I need that much here. So I'm just going to go from maybe -3 to maybe 3. Let's see if that's any better. Okay. All right, so it looks like I have how many critical numbers? 2, right? The derivative will be 0 right there and right there, right? And I don't worry about the endpoint because it's open there. Does that make sense? So I don't worry about the endpoint there. Okay, so to find them, I'm just going to put a 0 in there, go back to the graph, and do second trace intersect. Enter, enter, enter. So one of them is what? X equals what? 2. Okay, and then second trace intersect. Enter, enter. This time I'm going to move over to the other one. And I get x equals what? 1.25. Okay. And by the way, you don't have to worry about f being undefined here, because if f prime is defined here, then f will automatically be as well, won't it, if you think about that? There's no way f prime is going to be defined, I'm sorry, there's no way f's going to be defined at a number if f prime isn't also defined. And so is f prime defined at these two numbers? So therefore f will be, and therefore they are both going to be what? Critical numbers of the original function, yes, whatever it is, right? Okay, good. Okay, so now here we go. As we noted earlier, an absolute min or max can occur where again? At a what? Endpoint of an interval, or at a what? Or at a what? Hill or valley in between, basically, right? Agree with that? Okay, so now we're going to switch from local or relative mins and maxes to what? Absolute. Okay, so based on what I just said, we can use the following process to find the absolute mins and maxes. And again, if you try and memorize this rather than understand it, you're going to have trouble with it and you're going to not remember it well for the future. So again, don't just memorize this. Think about what we did at the beginning of the hour and how I explained things. And then this should make complete sense. Ready? Okay, so to find the absolute min and max of a function on a closed interval a to b, here's what you're going to do. You're obviously going to find the critical numbers, right? Because that's where the hills and valleys might be, right? Got it? Then you're going to what? Find the what? The y values at those critical numbers, and where else? At the what? At the what? Endpoints. Okay, and then from there, the largest y value will be the what? Absolute max, and the smallest y value will be the absolute min. Make sense? Okay, so here we go. Again, this first one I typed up for you so you can just watch and learn. Ready? Okay, so I'm giving you this function, and I want you to find the absolute min and max on this interval. Ready? Here we go. Okay, so the first thing we're doing is going to find the critical numbers of f. So I found the derivative, I factored out a 3, factored it further. Everybody agree that's f prime, and so where is that going to be 0 or undefined? Quick. At what? At negative 1 and 1, okay? Now, by the way, notice we're only on the interval what? 0 to what? 3. Is negative 1 even on the interval? No, so you can forget that one. So we really have to worry about what? The only critical number on our interval is what then? 1. Okay, so what I did then is I what? I calculate the y values, or f of x values, at the critical number and at the endpoints. So f of 0 isn't that an endpoint? Yes? What do I get when I stick 0 into f of x? What do I get? 1. Then I stick the other endpoint into the original function to get the y value, and I get 19. And then I stick the critical number, which is 1, into my original function, and I get 1. So everybody look at those 3 y values. What's the highest y value you see there? What's the highest y value? 19. So do you agree the absolute maximum is 19, and it occurs at the point what? 3 comma 19? Yes? What's the absolute min? What's the absolute lowest y value there on that list? What is it? Negative 1. And where does it occur? At what? X equals 1. Not too bad, is it? Okay, everybody try example 5. Give it a shot. Oh, wait, you know what? This one's definitely different. Sorry, I thought it was another polynomial. Why don't we do this one together? Okay, so here we go. Okay, so I want to find the absolute min or max. So what's the first thing I do here, James? What am I going to do here first? Find the what? Critical numbers, right? Okay, so here we go. So I'm going to find the derivative. That's 1 minus 2 times the derivative cosine's what? Negative sign, right? And so that simplifies to this, doesn't it? Okay, now obviously that's never going to be undefined, but it might be 0, so I'm going to set it equal to 0 and solve, right? And so I subtract 1 from both sides, and I divide both sides by 2. Okay, now Now again, we only have to worry about the interval what? 0 to what? 2 pi, right? Okay. So Sam, at what angle is x on the interval 0 to 2 pi will sine of x equal -1/2? What do you think? Pi over what? Well, first of all, which quadrants is sine negative, first of all? 3 and 4? Sorry, right here and here, right? Yes? Okay, what's the reference angle got to be, Sam, to have a sine value of 1/2? Pi over 6. Okay, so put a pi over 6 there and a pi over 6 there. Now, those are the reference angles. What are the full angles? Well, the full angle from here to here is what? 7 pi over 6, right? And then, what's the full angle here, guys? 11 pi over 6. But do you agree with those as being my critical numbers on the interval? Yes? Okay or no? Okay. All right, so from there, we want to find the absolute min and the absolute max. So, I don't want to write too small in here, so let me do this on separate paper. So basically what I need to do now is evaluate the original function at the endpoints, which are 0 and 2 pi, and then the critical numbers in between, which are this. Okay, everybody agree I've got to find those 4 values and then just pick out the highest and lowest ones, and those will be my absolute min and max? Right? Okay, ready? Write this down. Okay, so here we go. Okay, so I'm going to plug a 0 into the original function. Okay, obviously cosine of 0 is what? What's cosine of 0, guys? 1, and so I end up with 0 minus 2, which is -2, right? Okay? Now I'm going to stick a 2 pi in there. What's the cosine of 2 pi, guys? 1. And so I end up with 2 pi minus 2. And again, I got to be able to compare that to values that don't have pi in it. So what I want you to do is approximate that. I don't want you reaching for a calculator. Pi is just use 3.14 for pi. So what is that? 2 times 3.14 is what? 6.28. 6.28 minus 2 is about what? 4.28. Are you following me on this? Okay, see how I'm not using a calculator? Okay. Now, this is a tricky one. Stick in a 7 pi over 6. Okay. Guys, what is the cosine of 7 pi over 6? Well, first of all, that's the third quadrant, right, with the reference angle of pi over 6. What's the cosine of pi over 6? Square root of 3 over 2. And is the cosine positive or negative in that third quadrant? Negative. And so basically that's, all right, so here's basically what we get. Ready? Okay, if this is, what did we say it was? We just said it was what? Negative square root of 3 over 2. So if you put a negative square root of 3 over 2 and multiply by that 2, don't the 2's cancel? Okay, so we end up with this. Okay. All right, now again, hopefully I can just use, I don't know. If you use 3.14 there, what's 3.14 times 7? About what? 22 about, right? And what's 22 over 6? About 3.67, would you say? Yes? Yes? Plus, what's square root of 3? You guys should all know that the square root of 2 is about 1.4, and that square root of 3 is about 1.7. You should all know that. And so the square root of 3 is about 1.7. So when I add those together, I get about what? I get about what? About 5.4 roughly. Yes? Agreed? With me? Okay. All right, and then do the same thing here. 11 pi over 6 minus 2 cosine of 11 pi over 6. Okay. Again, use 3.14 there times 11. What does that give you about? About what? 34 maybe? And what's 34 over 6? About 5.67 or something, maybe 5.7 or so, just roughly. Yes? Yes or no? And then minus, what's the cosine 11 pi over 6? Well, that puts you in the fourth quadrant where the cosine is positive, with a reference angle of pi over 6. Again, what's the cosine of pi over 6? Square root of 3 over 2. Square root of 3 over 2 times 2. Don't the 2's cancel? Giving you minus what? Square root of 3, which again is about what? About 1.7. So this is about what? 4. About. Yes? Everybody agree? Good or no? Okay, so look at these 4 values now. And I want you to tell me the highest and lowest one. What's the highest one, guys? This one. So then the absolute max looks like it's going to be what? 7 pi over 6 plus 3, and it occurs at what? It occurs at what? It occurs at what? At 7 pi over 6? Now again, I don't even remember how the book writes that answer. They might just write that as a point, 7 pi over 6 comma that. I don't remember, but bottom line is that is the max and it occurs there. That's the bottom line, no matter how the book writes the answers. Is that clear? Yes? Okay. What about the absolute min, guys? The absolute min is what? What is it? -2, and it occurs at what? Occurs at what? At x equals 0. Everybody agree with me on that? Okay. And again, the book might just give that as 0 comma -2 or f of 0 equals -2. No matter how the book gives it, that's the answer. Yes? Are we good on this? See how I did that without a calculator? And you guys, I think that's another issue why my last test took you so long. You guys were relying on that calculator to get decimal answers when the book answers were not decimals. And that's why those related rate problems gave you so many problems. Do not rely on the calculator. You should never use a calculator on the homework unless I tell you to or unless the book tells you to. Is that clear? Okay, so don't go using a calculator on this. This is exactly what I should see on your paper. Okay? No cheating. You cheat on the homework, it's going to cause you to struggle and be tempted to cheat on the test, which obviously is a problem. Okay. So there's example 5. This the last page? Okay. Okay, let's look at this. Okay, we want to find the absolute min and max for this function. On the interval what? 0 to 1. Okay, so here we go. Again, no calculator on this. Okay, so guys, what's the derivative of e to the negative x? Yeah, well, it's e to the negative x times the derivative of negative x, which is -1, isn't it? So isn't it just negative e to the negative x? Isn't that the derivative there? Okay, then minus, what's the derivative of that, guys? Yeah, well, it's e to the u times the derivative of u. In other words, e to the -2x times the derivative of -2x, right? Good? Okay, simplify that. And is there anything I can factor out here? Again, you always want to factor your derivatives. That's the only way you're going to be able to find the zeros, right? Okay, so what do I do? What do I pull out here? Lauren, what can I pull out here? Okay, well, be careful. This has 2, this one doesn't, so I really can't pull anything out, can I? No. All right, so what do you do instead? Well, so what I want to do then is I'm going to rewrite that as this. Is that the same thing, yes or no? Can I rewrite that like that? Okay, and here I'm going to rewrite it as what? 2 over what? E to the what? 2x? Okay, now I want to get a common denominator, don't I? Okay, so don't I need to multiply this by e to the x over e to the x to get what I want? Everybody agree? See how I'm doing this? And once you get a common denominator, can I just bring them together under one fraction then? Okay, any questions on how I got to there? Everybody agree that's the derivative? And so again, in this case, I needed to get a common denominator to turn it into something that'll be pretty easy to find the zeros of. Without doing that, good luck. You wouldn't be able to find the zeros without going to here. Okay, so first of all, where is this undefined? When the bottom is what? 0. Is e to the 2x ever going to be 0? Think about what its rough sketch looks like. Imagine in your mind what the graph of y equals e to the 2x looks like. Is it ever 0? Is e to the 2x ever 0? No. Sam, stay with me. So, this is never going to be undefined, is it? Okay. When is this fraction going to be 0? When the numerator is 0. And so let's investigate that further. The question now is when is this going to equal 0, right? Okay, so all you got to do now is solve it algebraically. Ready? So I'm going to subtract 2 from both sides, get rid of the negatives. And now how do I continue solving for x here, guys? Take the what? ln of both sides, very good. Take the natural log of both sides. And that gives me what? X equals ln of 2. Okay? Okay, so that's my only critical number, isn't it? Is that my critical number? All right, now what am I looking for? I'm looking for the absolute what? Min and the absolute max for my function. Where can that occur? At this critical number, assuming it's in between my interval. Okay, we'll talk more about that in a minute. Or at a what? Endpoint. Okay, so the question is ln of 2 between 0 and 1? Well, think about that. Watch this. I'm going to draw a rough sketch of ln of x. What's the natural log of 1, guys? What's the natural log of 1? 0. Wouldn't e be right about here? Isn't e like 2.7? What's the natural log of e? What's the natural log of e, guys? 1. Okay. And then isn't there an asymptote here because the natural log of 0 is undefined? Okay. So that's roughly what ln of x looks like, right? So what do you think? ln of 2. Is that going to be between my interval, which is what? What's my interval? 0 to 1. Well, isn't this 0 and isn't this 1? So isn't that y value right there somewhere between 0 and 1? Isn't that ln of 2 right there? Do you agree that ln of 2 is somewhere between 0 and 1, so it is on my interval? Following me? It's cool? You following me on that? I mean, without drawing the sketch, you're going to have no idea if I should use this number or not to find my absolute min or max. Did you see why I needed to do this? Yes? Because if this was not even on my interval 0 to 1, I wouldn't even use it, would I? You agree I wouldn't even use it if it wasn't on my interval? Is it on my interval? Yes, it is. Okay, so we can now finish. Okay, so here we go. So at this point, I'm going to find g of 0, g of 1, that's my endpoints of my interval, right? And then I got to find g of ln of 2. Again, without a calculator. Are you ready? Here it goes. What's e to the 0, guys? Well, yeah. What do you get? 0. Okay, stick a 1 in there. Whoops. Don't need a common denominator there. So getting a common denominator, what do I end up with? You can do it in your head. What do I get? E minus 1 on top. All right, now I got to get an approximation for that. What is E, guys? 2.7. 2.7 minus 1 is about 1.7. And then what's... what? That? But I put it in the bottom to make it positive. Is this okay or not? Is this okay? Okay. All right, and then E squared is what? What's 17 squared? What's 17 squared, guys? 729? No. That's not right. What is it? Yeah, it's 2.7 squared. Yeah, what is 2.7 squared? 2.7 squared is what? Yeah, that is 7.29. Sorry. Okay, now that's, I don't know, that's somewhere around maybe what? A quarter or so, right? So about somewhere around 1/4. Everybody agree? Yes? Okay, stop there. Okay, let's go here. Put in ln of 2. Okay. Now, you guys, I know it's tempting to drop out the e and the ln, but I can't because of what? That negative. Is it okay if I put the negative up here on that and make it this? Can I do that or not? Sure. Same thing here. Can I put that up there on that as an exponent? But you see what I did there? And now, can I drop out the e and the ln? Yes? Same thing here. I can drop out the e and the ln, right, from algebra 2. Is that right? Which is what? Negative. No, I'm sorry. That's about 1/4, isn't it? Yes? Wow, that's going to be a really close call, isn't it? Yeah. All right, well, now think about it. If I multiply that by 4, what do I get? $6.28, right? Yes? So if the denominator was 6.28, it would be 1/4. Do you agree? So is this bigger than 1/4 or smaller than 1/4? Is this bigger than 1/4 or smaller than 1/4? Smaller. Okay, so then what's my min here? Well, first of all, my min is what? 0. That's my absolute min, isn't it? And it occurs at what? X equals 0. What's my absolute max then? What's my absolute max? 1/4? Yes? Everybody agree that 1/4 is my max? Okay. So that was a real close call, wasn't it? Yeah. Okay. But again, I did everything without a calculator. This is good stuff. So I don't want you guys, cheating and using a calculator on this on your homework. I don't want you doing that. All right, so the rest of it will go pretty quick, guys. Ready? All right, so I want to use a handmade sketch to find any local mins and maxes and then any absolute mins and maxes for this function on the interval 1 to 4. Are you ready? Okay, well, first of all, let me use a pencil. Okay, first of all, what's the parent function? Y equals absolute value of x. We should all know what that looks like. What does that look like? So what? V-shaped curve starting at 0, 0 and opening upward, right? Yes? With the vertex at 0, 0, right? Okay, what happens? You subtract 3 inside the function. Everything goes what? 3 to the right. What happens when you add 2 on the outside? It goes 2 up. Okay, so just to get an idea then, the vertex is definitely at 3, 2, and then it goes like this, doesn't it? Yes? Everybody agree? Okay, now I want some more points, because this has got to be really accurate. So why don't I plug in a 1 to get the endpoint value? Plug in a 1, what do you get? Quick. Everybody agree you get 4? Okay, plug in the other endpoint, which is 4. Plug in a 4 there. What do you get for the y value? 3? Okay, so everybody agree that that's what it looks like? Yeah, I don't know what the hell. That's strange. Okay. Everybody with me on that? That's what the function looks like on the interval 1 to 4? Okay, so now it's pretty easy. Just look at it now, guys. Where's their local min at what? At what? Yeah, at the point 3, 2, right? But agree there's a local min there at 3, 2? Is there any local maxes here? What's the absolute min? The absolute min is what? Well, yeah, it's 2, and it occurs at what? At x equals what? 3. In other words, at the point 3, 2, in other words, right? Everybody agree? What's the absolute max? 4, and it occurs at what? X equals 1. In other words, the absolute max occurs at 1, 4. Everybody agree? Okay, now I want to use the graphing calculator again to find the local min or max and the absolute min or max. Ready? Here it goes. It's coming from the ceiling. I know that. Maybe they're working up in the ceiling. I don't know. I don't know. Again, I'm going to make sure my calculator's in what mode here, by the way? What mode do I have to be in here? Radian mode? Yeah. You're going to make me laugh. Stop. All right. Remember, I'm recording this. Okay, so now I'm going to start by hitting zoom z trig, right? Anytime there's a trig function involved. Okay, start with zoom z trig, and then, Sam with me? It's getting worse, isn't it? Now I only want to be on interval what, though? 0 to what? 2 pi. So go to window. Maybe if I talk long enough, we won't hear it. Okay, and then go to 2 pi, right? Is this good? Everybody see what I'm doing there? Then hit graph. Okay, so where's the local, first of all, is there local min, guys? By the way, you know what? I can't really tell what's happening there. It's definitely not going flat. So I'm going to stretch this out vertically again, kind of like I did a few minutes ago. Let's maybe make it -2 to 2. That'll stretch things out, give me a better picture of what I'm looking at here. All right, see, it's clear now, it goes down. Okay, so clearly I have a hill there and a valley there, right? Isn't that my local min and max? Okay, so how do I find hills and valleys? You did this back on this summer packet. How do you find hills and valleys? Second, trace, right? Minimum. And then, am I to the left of my minimum? Yeah, just hit enter. For right bound, you move to the right of my minimum point, hit enter. And guess you move down here. Okay, so there you go. So 3.665 comma -0.577. Everybody agree? That's my min, local min. Okay, do it again. Second trace, this time maximum, right? Okay, set my left bound right about there, hit enter, go past the point for the right bound, hit enter. On guess, move to the top and hit enter. Okay, so there's my hill or local max. Guys, I'm telling you right now, you're going to have to do one very similar to this on the calculator part of your next test. Okay, obviously, this is the only one like it I'm doing. So make sure you practice the couple I assigned on your homework tonight. Okay, now what about the absolute max, guys? Well, it's kind of hard to tell what's higher. Is that higher, or are we higher over here at the beginning? Which one's higher? Well, let me find the y value over here. How do I find the y value over here at the beginning? Second trace value and type in what? 0. Okay, is 0.5 higher than 0.577? No. So what's my absolute max? This point again, isn't it? Yes? And then what about the absolute min? Clearly the absolute lowest point is down here, which is what? Yeah, 3.665 comma negative 0.577. Everybody agree? Yes? Everybody see what I just did? You're going to have to do one or two just like that on the next test. Okay, last problem. All right, you guys, remember I said there's only a few theorems you have to learn? Well, this is the next one. The extreme value theorem is exactly what it sounds like it might be. Ready? Okay, and it's actually kind of common sense if you think about it. What it says, if you've got a continuous function on a closed interval a to b, then the following must be true. What is it? And the function must have a what? Absolute min and a what? Absolute max. Now again, a couple notes here. What does it mean for f to be continuous? It can't have any what? Holes, breaks, jumps, or vertical asymptotes, right? Okay, and we know, as was stated earlier, that f can have a what? Absolute min or max at more than one value. Didn't we discover that very early in the hour? Right? It can happen at more than one x value. Okay, so isn't that common sense that if you got a continuous function, it's got to have a high point and a low point somewhere on the interval? That's all that says. Okay? Are we good? Okay.